let's take a look at number 34. First and the last position of elements in the sorted array. We're given an arms array sorted in ascending order. Find the starting and ending position of a target. The complexity must be in log of a log O log n. So this is another hint for us to use binary search. If not found, we just return -1 and -1. Yeah, it's kind of just like what we did in the last problem, which is 33. We'll just find an element in a sorted, rotated sorted array. Let's first analyze the array. So actually, there will be a three subarray, S1 to SK, and then target SL to SN. Every time we pick a number in the middle, there are three possibilities. So the first one is it falls into the left. Then we can just recursively do the search and to the right part. Just as the same, if it falls to the right, we can search to the left. If it falls in the middle, we should search the left boundary to the left part and the right boundary to the right part. So if we're doing it in recursion, we actually needs to have three patterns. So what we should return. So let's just create the search methods. The first one is start, next one is end, and there is mode, right? Okay, let's say mode 2. Mode 2 is return the range. Mode 1, return the left boundary. Mode -1 is the left boundary. It doesn't matter what the number is, just give them three constant numbers. Return the right boundary. So let's first, if we're given this kind of params, we first get to the middle. And if mode is 2, if we need to return a range, and if nums middle is smaller than target, it means it falls to the left part, so this subarray. So we can safely do the search, return search I, not I, but middle +1 J2, right? Else, if it's to the right part, it falls here, then do the same search I middle -1 2. Last, if it falls to the middle, we need to get the boundary from the left and get boundary to the right. So it's a search I middle, because the boundary might be itself, so it's not -1 but middle. -1 search middle J1. Okay, this is done. If mode is search left boundary, we need to find the first number of target, which the left of it is not target, which is the boundary, right? So we just need to check. There are only one to check. We need to check that whether the number is target or not, because the right numbers to the right are all target. So if nums middle equals target, if it is first number, or the left number of it is not the target, right? So if middle is equals to I, or numbers middle minus 1 is not a target, then this is the boundaries, right? So return middle. If not, for the other case, then it means there's still a target at the left of it. So it should be return the search I middle minus 1 minus 1. For the other case, if it's not target, then we should search the right, right? So return search middle plus 1, not middle plus, yeah, middle plus 1, and j minus 1. And we should do the same for mode 1, copy it, middle equals target equals j, or it's plus 1 equals target, so it's target, it's the right boundary, or it should what because it's target, but so there is another target to the right side of the target, so it should be plus 1, and here should be j. If it's not target, then there, yeah, we should search I and middle minus 1. The mode should be 1. And of course, if I is bigger than j, we should return minus 1 minus 1. And that's done. So we return search 0 length minus 1. The mode is 2. Let's run the code. Yeah, accept it. Yeah, it's passed. Let's analyze the time complexity. We use a recursion, but actually each number is traversed only once, so it's very... the worst case is that every time we need to check the middle, every time it falls into the target, and that's actually all of them are 8. We would need to find 8 and then find the left, find left, find left, find right, find right. So it's actually 2 log n. It's what I think. So it's actually O log n. It's okay. But the space a little different. For if it falls in the middle, we got this stack, got this, and do the recursion. Middle. This is not tail. It's actually here only one flow, one depth, right? It's stack, but it's tail recursion. So actually, there only extra one. This one will create a layer of stack. So actually, it's also constant. It's fast enough. Anyway, can we rewrote it into that iteration fashion? Let's try. Let's remember that the iteration is just to use two cursor iteration time. Let's do this at the end of this video. So this I, let's I equals 0, let j equals num starts length minus 1, while I is smaller than j, while I equals to j. Ah, no. If we do this, the time would be O log n. Oh, no. No. It's. Oh, it's okay. It's okay. So this also gets the middle, which is math floor I plus j divided by 2. Now, just as what we did in the last comparison. If middle is smaller than target, I equals middle plus 1. Else, if middle is bigger than target, j equals middle minus 1. If it equals to middle, then we need to find left boundary. How could we find the left boundary? We need to move the I think move I to the, wait a minute. If we move I to the left middle, yeah, that would be a better. No. If we need to find the left boundary, so how the I, if we got something like this, it's just in the right middle. Can we just move the I here? No, if left, I think the check here, it should be done. So it's actually should be break. And now we need to find the left boundary. The left boundary, we let, okay, I, j, and the middle, we need to find a number between I and middle, right? So let k equals middle, while I is smaller than k. While ki is smaller than k, const middle left equals math floor I plus k. We get the middle of the left possible left boundary. This is this. If just as what we did, if middle left is equal to target, if it's equal to it, if middle left is equal to I, or nums middle left minus 1 is now target, then it should be here, so you just break. In the other case, there's another target A to the left, so K should be middle left minus 1. If it's not equal to target, then I should be target plus not target, but middle left plus 1. So this is how we get I equals middle left, and then we copy this part, find the right boundary, we use L, while L is smaller than J, middle right, LJ, middle left, middle right equals J, and middle right plus 1, it's not target, then J should be middle right, break. If not, then if not, there's another number to the right, so L should be middle right plus 1. If not, then we should move J to the left of middle right. So yes, we break. And so at last, if I is smaller than equals J, we return ij. If not, we return minus 1, minus 1. Let's test the code. I hope it works. Oh, God. Oh, it doesn't work. Okay, let's console log I j, console log I k. Console log L J. So 0, 5, and then we check 3, 5. Okay, we check 3, 5. We just break, right? So we need to get the middle. Middle ij, so middle is 2 actually. 2 is this one. Okay, this is to the left, so I become 3. So we check 3, 4, 5, and the middle is 4. Ah, God, it's nums middle. Nums middle. We run the code. Oh, it seems to work. Let's remove the console log and submit. This is first time I try this. Yeah, it passes. Good. So let's take a look at the time. It's actually the same as what we did in the recursion. So here, so every element is actually the first one. In worst cases, that we break here and then find the left boundary and right boundary, and this worst case is unlock half of n. So together it will be the same as the recursion space. This is much simpler than the recursion because we don't need to analyze the call stack. We only use two variables to keep track of the index, so it's actually a constant. That's all. So I hope you can learn something from the iteration and recursion, and pay more please pay extra attention to the tail recursion and non-tail recursion. If it is non-tail recursion, we need to improve the recursion by rewriting it into iteration, because it will add extra, usually log n, the space complexity. But in our case, there's only one call stack here. In the other case, actually it's all tail recursion, so it's okay. That's all for today. See you next time. Bye bye.